All right. So I kind of promised you guys another another method, another exploration, should we say, of this problem. When we were first looking at the toolbox for it, we said there's a couple of ways we could go with this one, right? And we talked about how writing everything in terms of sine and cosine right off the bat. I said if you did that, it might not have been the best method, right? Then we talked about finding a common denominator and combining fractions. And we said, and that, is an option when you look at this, okay? Even though this isn't a fraction, we can make it one. There's a lot of ways we can make it a fraction, to be honest. And then we talked about multiplying a binomial in a fraction by its conjugate to produce the difference of squares. And even that there is potential for that in this problem, okay? So while we're here, let's see, which one do we want to do? We're going to skip this one. Finding a common denominator and combining fractions. Okay, so I don't know how this is going to work, but why not? Let's try it. Let's write this as cotangent x over 1. Now it's a fraction. Now, simplifying, one interpretation of simplifying would be taking two fractions and combining them into one. So if we wanted to combine these fractions, we could by multiplying by secant x on the top and bottom here, okay? And that would create a fraction over secant like so, and in the numerator of that fraction would just be this product. So I'm going to combine that into one fraction right away, which would be 1 plus cosecant x minus cotangent x secant x over secant x, okay? Now, here we obviously have a huge mess. And I said from the beginning that writing everything in terms of sine and cosine right off the bat for this one might not be the best choice. And the reason for that is because we have this constant, okay? And this would have been what, 1 over sine x with this constant in the numerator, okay? That's tough. What are you going to do with that, right? You would have to turn this into a fraction. It could get messy. So we're in this situation now, and we don't know where this is going to take us, okay? But we do have these three terms all in terms of not sine and cosine, but we can write them in terms of sine and cosine. So if we do that here, now that we have more terms in the numerator, let's see what happens when we take that route. So let's write our cosecant as 1 over sine. Let's write our cotangent as cosine over sine. And let's write our secant as 1 over cosine. Let's see what that gets us. Now, the bottom is still secant, and we can write that as 1 over cosine x. But really, the idea here is this problem gets simpler when we only look at the numerator first, right? So let's see what we can do in the numerator and simplify that, and then we'll deal with the fraction after. Of course, that's not the only approach, but it is the approach that we're going to take. We're going to simplify the numerator first. And what happens here in this product? We can multiply these together and simplify it, and what's going to happen, right? Cross cancel with these cosines. Now my numerator looks like this. And what do you notice? Okay, I still have this 1 over cosine x down here, but in the numerator, we have opposite terms. Those opposite terms are going to cancel, leaving us with just a 1 and a 1 over cosine x. This is a fraction sandwich where the fraction is in the denominator, and the shortcut when the fraction is in the denominator is to multiply it into the numerator. So we end up with cosine x over 1, which is just cosine x. So we did get to this point. The tools that we used, okay, we found a common denominator for the fractions. And then after we found that common denominator, we combined the fractions together. We wrote everything in sine and cosine form, and we were able to get out of that by having these terms in the numerator cancel. So we got a little lucky there, okay? Is that the only option? No, it's just another option.